Good morning. Welcome, everybody. Thank you very much for being here. I'm the Senior Vice President and General Manager of Dell Technologies Federal, and representing a company that has always been about bringing technology to market to enable human potential. As Dell has grown over the years, made a couple of pretty significant acquisitions, EMC, VMware, Pivotal, RSA, etc., we have shifted that vision in Federal to be more solution-oriented and to focus specifically on bringing solutions to market that offer speed to mission value. So it's a solution orientation to enabling human potential in a much more bigger picture, rapid way. Today, as we talk about artificial intelligence, we know the government is working on moving through digital transformation and beginning to engage with artificial intelligence, which is a mature technology, in a very serious way. As a matter of fact, areas of government are way ahead of the rest of the commercial sector of the United States, with a couple of notable exceptions, like financial services as an example. Government actually is, in many areas, way ahead of the rest of the commercial market space engaging with AI. So first, I would like to ask the room, who in the room is actually is an IT person delivering solutions to their agency using artificial intelligence? Can I have a show of hands? Okay, so we have about maybe 5 or 6 people. How many folks in the room are a consumer of IT in an agency where you know that you're the recipient of capability enabled by artificial intelligence technologies? Okay. Yeah, so about a half a dozen and half a dozen, okay, in a room of hundreds. So what that tells me is that our number one mission right now is actually helping government get going, right? Get their toe in the water of artificial intelligence. Bring the technology into the agency, create a test bed, and begin actually experimenting. As you do your digital transformation, work to execute on artificial intelligence simultaneously. So it's my absolute honor and privilege to moderate a panel today. As we said earlier, we have 3 distinguished gentlemen that are actually deeply, deeply engaged and have been for many years delivering capabilities with artificial intelligence. First, Dr. Jonathan Howe, who is recognized as one of the UK's leading experts in deep learning and machine learning. Jonathan has dedicated his career to propelling governments forward with technology. Notably, Jonathan has developed many tools using machine learning and optimization methods for both the US and UK governments, particularly in remote sensing, ISR, and security. In his role on the federal solutions team at Nvidia, Dr. Howe specializes in deep learning and artificial intelligence for defense and intelligence applications. Jonathan is a recipient of the Ministry of Defense Chief Scientific Advisor Award, the Arnold Award for Outstanding Applied Research, and was awarded an Operational Service Medal for his field contributions. So thank you for being here, sir. Also joining us is, trying to get this in order here, Todd Myers. Todd is on the end here. Todd is the automation lead for the National Geospatial-Intelligence Agency. Todd provides collaborative support to agency leadership and advisement for strategic IT planning across the NGA. Todd has been leading his team to develop a strategy to deploy a multi-data center capability to put machine and deep learning capabilities in theater globally, which represents the NDAAS, or NGA Data Analytical Architectural Service. And so Todd is delivering that on a global basis in support of mission partners. Okay. And finally, we have, I think that somewhere. Yeah, Brian, I don't know where the heck you went. And Dr. Brian Sadler. Dr. Sadler is with the Army Research Laboratory and has developed 20 questions to help people engage with artificial intelligence. And since I don't have your bio in my deck here at this point, I'm going to allow you to further introduce yourself, and then we'll get started with the panel.
Okay, thanks.
Thanks, Brian.
I'm the Army Senior Scientist for Intelligence Systems. I sit at the Army Research Lab, which is the corporate research laboratory for the Army. And I'm pretty broadly engaged in research with academia and portfolio management. And as you can imagine, AI and machine learning is impacting just about our entire portfolio.
Thank you very much, gentlemen. Okay, we're going to get started here. First of all, and we can start with Jonathan. In your current role, could you describe your work with artificial intelligence technologies?
Yeah, sure. So as a senior solutions architect, my role effectively is to help customers achieve what they require from artificial intelligence for a diverse set of applications within government. So that includes, teachings through our Deep Learning Institute initiatives within the labs. We also we create blogs. Senior solutions architects produce blogs to help describe methods and techniques to try and understand or kind of transform a data set into a series of kind of labels or what it may be, predictions. So for example, we produced blogs on the SpaceNet challenge, which is an open challenge that was over the last few years. So we produce blogs in that case. We meet with customers to describe how they might best, say, procure hardware for their particular use cases, and also provide kind of ideas and concept demonstrators for how they may develop applications for their use cases.
Great. Brian?
So I gave a little bit of preview of what we're doing. So we have to focus on our precious few dollars on things that are specific to the Army and that Google won't solve for us. The Army has a huge number of challenges. Looking forward to something like 2050, it's anticipated that a large amount of the population of the world will be in dense urban, and we're going to have to operate in those kind of conditions without infrastructure. So we have many problems across autonomy, data, analyst, wireless networking, and so on.
Great, thank you very much. And Jonathan, would you please answer the same question? How are you bringing AI to bear in your current role?
For a second here. So my name
Todd.
is Todd, that's okay. About 4 or 5 years ago, we, NGA and the IC community and DoD, embarked in an activity to migrate a lot of our architectural activities that have been historically deployed inside of data centers and move that to the cloud. And to the cloud was primarily what we called C2S region of Amazon services. And so in that process, we've taken some classic steps of system engineering, designed monolithic environments, and lifted and shifted those components into the cloud. And over the couple of last 2 years, actually, we've taken lessons from Google and Uber and Airbnb and Lyft to rethink and embrace technologies such as containerization, Docker, resource offer clusters such as Mesos and other components to then enable us to take the analytic components of our systems and focus on that versus the entire system itself. And so part of the activity that I've been leading over the past 2.5 years has been able to take almost 100% of a sensor data, as an example, that historically was not being processed in a timely fashion, and provide 100% of that data into the cloud and process it using the same exact technologies that Google and Apple and Facebook are using today. In order to do that, we had to distribute a new architecture that lets us abstract the infrastructure of the hosting environment. So what we didn't want to do was be bound to a specific set of APIs that Amazon requires you to write your code to, because we knew we wanted to go to other places. So for us to be able to have the ultra transportability of the code was important. So am I not coming through here? Okay, so we have effectively taken the code that was concatenated inside of very monolithic system designs and have freed that code so it can now be distributed on any type of distributed cluster, and we are keenly aware of what's required to do that to enable containerization and enable effective use of CPU and GPU resources. So all of what I just mentioned is wrapped up in an activity we call NDAS, NSG. It supports not only the National System for Geospatial Intelligence, but also the Allied System for Geospatial Intelligence, our consumers, for mission to receive these analytic outputs via a very well thought out series of clustered analytic computing environments. So we focus on the algorithm, not the architecture itself, but the data being run in a container, and the container can run at any mission site or any other environment, as long as the resource clusters are providing those resources to the environment. So I'll stop there and we can continue.
Great, no, that was very, very insightful, thank you very much. The next question is around technology enablers and technology building blocks in the adoption process. And so what are some of those critical technologies, building blocks that are required in the adoption process? Jonathan?
Being from Nvidia, I would say GPUs.
Yeah, well, we would agree.
Yeah, but they are at the moment they are the kind of the best route towards AI. The reason why they're so effective is because they do large scale parallel processing. The memory bandwidth between the actual memory and the chip is just absolutely highly performant. And because of that, it enables neural networks, in particular, to be trained and to be inferred upon, feeding forward the data throughout the network in a very, very high performance way. So I would say that that there are multiple kind of hardware solutions that you can use that are kind of out the box in order to bring AI to your particular use case. One big kind of key part of it as well is the software, as Todd mentioned. So a lot of the software itself, in terms of the underlying libraries, are developed by Nvidia or supported by Nvidia. So CUDA is the kind of the initial kind of underlying library that enables this to occur in terms of being able to write kind of highly parallel code. But then since about 2014, we've got other primitives such as cuDNN, which allows you to do these large-scale neural processes. And all this is very easily accessed. And in addition, just for the last couple of years, NVIDIA has really invested a lot in Dockerization, containerization of software, which allows for this kind of migration from the kind of the training environment to the inference and deployment environment. In addition to that, we do support all the frameworks, so all the learning frameworks with TensorFlow and others. And what we do is every month we release a kind of a streamlined, highly performant container of all the major frameworks, so TensorFlow, Caffe2, others, which allows researchers to easily download, pull those particular containers and run and mount your data in that particular environment. So you can train, if you have a piece of hardware such as a DGX1 and you pull your container, you can be training within minutes effectively from switch on. So I would say it's a combination of the hardware, such as DGX, and containerization, which really allows you to accelerate your access to AI.
Great. Todd, what are your thoughts on technology enablers and technical building blocks?
So for us, it was so it's more of a series of software release practice, rigor. So in the days past, things that John just mentioned were only accessible to folks who actually had those things in their environment, or they had access to a data center, or they had a large budget. So it's really simple for us. Code to source, master branch to a Jenkins CI/CD release schedule, to a namespace containerization deployment onto a cluster. It's really that simple. And so that process in and of itself, it greatly enables and it greatly accelerates the delivery of idea to source, to namespace containerization, to resources that are required to be used, evoked. And if you want to get down to the things of technologies that are specific to what we're using, yes, we're using Tensor, Caffe, MXNet, Spark ML. We're using all those things right now, but we're using them kind of in a hybrid software-based environment. I would love to have access to a physically bare metal hosted set of NVIDIA GPUs in C2S, but I don't have that. What I have is a resource pool of not the most to date, GPUs, but I have a pool of them. And so I have to focus on my abstraction of software that takes full advantage at the kernel level to execute the CUDA libraries down to, based upon a resource offer of that pool of resources. So in some sense, it actually gives me more flexibility to allow software to outline the orchestration of how algorithms are orchestrated. And in the other sense, it's a very limiting because I don't have bare metal. Ability to take full advantage of actual in-memory processing, actual physical GPUs. So there's pros and cons, but where we are in the movie, and for some of you in the audience here, if you're thinking of going to the cloud and you're thinking of transitioning your systems that are back office or things that you want to do, inferential learning from your HR deployments and things of that nature, there is no silver bullet, one silver bullet. There is a whole plethora of things that you have to consider, which is why we offer Kubernetes and Docker and Tensor and Cafe and MXNet and SparkML, and there's probably half a dozen to a dozen other things.
I think you have one of the mics on that's not on the panel.
I don't know what that is.
Probably we don't want a Naked Gun thing going on here, so.
So let me turn this thing off here. I'll just yell. There we go, turned it off. Okay, is this better?
Yes.
Okay. So we realized that we needed to enable our developers to compose, to paint, right? So I provide blank canvases that are fully enabled to have any type of palette that they want to compose against, right? So if they are if they're learning how to compose a Docker file and they are more proficient in their CI/CD process of understanding Git and building actual artifacts, that's great. We're the catcher's mitt of that. If they aren't understanding the designs of the great Adrian Concroft for 12-factor and ThoughtWorks.io and leveraging and getting out of MATLAB as a way that they are comfortable with and using just IDL libraries and maybe perhaps go write natively in Go or Go and Python, then that's fantastic because then we can implement a more upfront streamlined process of how the code is actually brought into an environment so that we can take it and namespace it for them and deploy it. So the technologies are vast. The mix of technologies are vast. We don't dictate on what people can use. We just enable them to not worry about the system, the underlying infrastructure, and even the abstraction of said underlying infrastructure, and we let them focus on the execution of their code, their algorithm, to do change detection, training sets, neural nets, deep learning, things of that nature.
So just to break it down a little bit, we talked about the need for a vast resource of computational capability. And it sounds to me like you're describing a really well thought out software factory type of approach to deliver an AI capability out to the agency. Is that fair to say in a very oversimplified way?
Yeah, we wanted to take the onus of, we wanted to get rid of the methodology of system integrators and companies building in their factory and then showing up at our doorstep. I want MIT, Lincoln Labs, Arizona State, Caltech. I want them to promote their code to Git. I pull it down on the low side. I bring it in. I DTO up to the high side, transfer up to the high side, and we start iterating on that.
Great, thank you. And so Brian, building on that, what are your thoughts?
So I can pull on that thread a bit. So, into the lab, of course, we're doing the same thing. We're beefing up HPC. We're going to bring in containerized GPUs, and et cetera, right? And then we have to worry about software across, open access and so on. Another thing we're really worried about is getting the right kind of data because ImageNet does not solve my problems. ImageNet is pristine. My environments are not pristine, nor are they pristine.
It's kind of like a lightsaber.
But what's interesting, and so because we span the whiteboard in the academia all the way through, now we're working towards a business model where we have a very tight loop between the data, the algorithm, the application, the user feedback. Right? So we're trying to get away from this sort of old, stale, linear model, which says I progress from 6.1 to 6.2 to 6. Somehow magic happens and transition occurs. And because this kind of, the paradigm we're in, which is data-based and learning-based, means that we are empirically driven. Right? So it's not like I'm going to design a radar and I can say to you in 3 years, I want you to go through this narrow wicket with this many decibels and this. I can't do that. I don't have physics-based reasoning or modeling for this kind of learning. So we're really into an empirical mode, which means that we have to embrace spiral development, which means that we have to have the infrastructure. Right? We have to establish this infrastructure like you guys are doing that's going to be sustained and long-term. Because I'm going to have partners coming in and out. I'm going to go down a path and learn a lesson that, gee, I went down the wrong path. So we're going to have to be prepared for this way of doing business. So all of that infrastructure, I think, supports the notion of data collection, empirical spiral development, and feedback with the user in a very continuous way.
Great, that's super helpful. So it's really that closed loop continuous feedback that allows you to develop on. It sounds like a very agile methodology.
It's easy to say and it's hard to do. And honestly, when I look at the Army S&T process, we got to break down some barriers. So one of the messages I'm constantly preaching to leadership is, you got to think hard about this. You got to think hard about new business models. You got to think about code sharing. New lanes are going to develop, and we have to think carefully about, should I just stay in my lane? How can we team better, and so on.
So as the three of you bring these capabilities, this is a custom question. So as you bring these capabilities to your internal market audience, what's your time to value target? How long should it take you to to go from the idea or let's say a well-articulated need by one of your users to an actual productive capability?
Well, if you're Google, and so I was in a workshop a couple years ago, and Peter Norvig was there to name drop shamelessly. He's one of the AI R&D leads for Google, and he was asked this question, and he said, we look to productize within 1 year. 1 year. When I look at things from an Army perspective, I have to balance near and mid and far, and I don't want to ignore the far. But when we're just talking about algorithms, the time scale is getting really compressed, and now we're feeling a lot of pressure to show early wins. So we have this sort of conundrum, actually, in the research world, which is to think long-term, but show me something really meaningful in a really short period of time. I don't think there's an easy answer to this, but definitely software products should show usefulness with real data relatively quickly. On the other hand, I'm not going to field a autonomous driverless tank in the near term.
So so earlier I talked about the software release schedule rigor, and so there's a term that I really despise. There's a couple terms I really despise. One is requirements, the other one is transition, and the reason I despise those words is that they separate those activities. And so what we're talking about is not separation anymore. We're talking about connective tissue. It's blood flow through the human, think of it as blood through the human body, right? So I am not going to stop a developer in research who is working on a fantastic change detection algorithm from interacting in the operational metrics that they need to expect, right? So my methodology that we're implementing at our agency with my team is that anybody who releases code has continuous connective tissue to how it is deployed into ops. And when it goes to ops, guess what? No one touches it, right? If it's not working in ops, you do another release schedule and you do a blue-green deployment. It's no different than what Google or Amazon does today. So this notion of this line of demarcation, throwing it over the fence, is a false pretense because it goes completely against the grain of 12-factor app design. It goes completely against the grain of iterative release schedules, and it goes completely against the grain of learning and failing hard fast, right? So it's a mere fact of if you want to get to SpaceX type of commercial deployments, right, then you actually have to break down the legacy process, and the legacy process doesn't get you to effectivity of mission. So you asked the timeliness, it's all relative, but if I can get an algorithm that's doing object detection of a sensor phenomenology, and rather than waiting 2 years for release schedules of effectivities, is another favorite word of mine, and I can get that into a month schedule and get it released and interrogating that data, then that's a mission effective win. So.
It's great. Great insight. Thank you.
Yeah, just to kind of reinforce what was previously said. So what you find, what I have found at least, is if you are generating a concept demonstrator to say that you're going to get to some particular capability, say detecting vehicles or something like this, usually what you would do is you would use whatever data sets you have available with labels, very well labeled data, and usually that exists exists kind of externally, so you have to use some kind of proxy data set, kind of open source data set in order to prove some methodology. So you can do that relatively quickly, say within 3-4 months, but then you need to transfer that to real data. And it's an organic process. It's, again, going back to the spiral kind of development. It's not just, okay, here's a drop, that's it, it's finished. You need to start off with what you have available to you, and then build upon that. And then when you do field it, that's not the end. You need to continue to build that capability based on this feedback cycle. Again, it requires breaking down some legacy processes, I believe.
Great. So I'm going to ask you to think about the answer to this question in non-technical terms. As deep technology experts in artificial intelligence, knowing that many agency leaders and mission leaders are trying to solve to bring artificial intelligence capabilities into their area of operation, what practical advice would you provide them on getting started? And anybody can answer that.
So I get asked this question a lot. And so one way I phrase the answer is the following. So the Army has old problems. We need radars. We need vehicles. So I say, well, let's say you want to add AI and make a cognitive, intelligent radar. Number one, get your radar expert. Number two, get your radar expert who's AI fluent. So that's one way I think about, right? And we're slowly all becoming AI fluent. Some of us more slowly than others. And this is a major challenge in this area, is to become fluent. And I speak this as someone who lives in the area. It's not trivial. It's not simple. And you should expect a large variation in understanding. That's not a bad thing. So. But your question was, what do you say to leadership about getting started? Make sure you have the domain expert, and then, try and get somebody who's AI fluent in the domain, right? It's the combination, right? Because I think of AI as a toolbox. It's not a thing, right? It's a toolbox. And there are many really interesting tools, not just neural networks, many other tools, machine learning tools. And the toolbox is becoming incredibly rich over the last 10 years, dramatically so, in my opinion. So, get smart in your domain and then get smart in AI.
So it's really about unlocking the value in what is probably relatively deep subject matter expertise in a domain that exists through bringing the technology tools to bear in the area.
Yeah, and you're going to have to try a lot of different tools because, if we're just data-driven, it's empirical, like we've all been saying, and you're going to have to try it and see. This is the common term in computer science today, try it and see. And, so you can expect some major flameouts, for sure, because you can't predict. You cannot predict how well you'll do.
So, Todd, do you have any thoughts on that question?
So getting started on AI, I'd rather have a plan. So I'd give the advice is, what are you going to do on day 2? So if you're getting started with the goal on day 1 running, what are you thinking about day 2? So it's more of, do you think that AI is going to be embraced in your organization? Have you thought about all the other business practices that are required without AI that you could leverage to be more efficient? So AI just didn't show up, and neural nets and change detections just didn't show up. It's actually been around for quite some time, 30, 40 years, right? So we're just now able to commoditize the ability to execute those algorithms more effectively now. I'll give you some examples that we've embraced. One of which was to use more machine learning approaches. I wouldn't stretch to AI, but more machine learning approaches to just understanding what we had at our organization with respect to what each individual had described in their resume, right? What was their work history? And by applying these technologies to iterate through their credentials and what they're capable of doing, where they've worked, where they want to go in their careers, was greatly assisted by these types of machine learning type of techniques. I wouldn't go as far as to say that we kicked off AI to then discover the best candidate for a new job. Not that couldn't happen with some things such as blockchain distributed ledger type of capabilities that really is just going to be so abstracted to folks that you'll never even know that a distributed ledger is now doing your bank account in banking. Oh, by the way, it's already being done for you today. There's not a single bank that's not using a distributed ledger, a blockchain technology. So it's more about, do you even have a need for AI? If you do, or have you, like Brian was mentioning, have you harnessed or pulled together the experts? And if you don't have the experts, do you even have a campaign within your organization to go out and identify the experts to come in and be part of the new culture? Actual mathematicians and folks several individuals that comprise the execution of data science tradecraft. There is not one person that's a data scientist. It doesn't exist. That person does not exist. There's an aggregation of a data scientist, of a mathematician, a historical forensic person, psychology background, and things of that nature, which really is an entire team. So if you're an organization that's going forward and you want to get execution towards these principles, where are you in the movie with just prior to what I just mentioned? Where are you in the movie understanding who's in your workforce? What skill sets do you need on the horizon? Do you have the technology expertise in-house to even take a system that's in-house and move it to the cloud? Have you thought about the architects and the cloud certification folks that need to be there to be able to identify and be cognizant of how to even converse using things such as Amazon or another type of cloud environment? So if you did all that, and then you picked an activity that you were going to refine, then I would say that AI would come to bear. But I do have it's a little bit of a downer. I have a kind of an observation. I find it quite amusing where companies that a week before had never uttered the word AI and ML, and everything that they're presenting to me has AI and ML written on it. So only come with the experts and let the experts have the conversation. It's not a slick sheet term. It actually has deep meaning and deep expertise that comes with that. So let the data scientists present those teams, and let the individuals that are representing this type of high algorithmic mathematical algorithm development, let them be the forefront of the conversation.
Great insight. Thank you. Time check, about 3 minutes left. Okay, great. So we got about 3-4 minutes left, and just to continue to build on this conversation, and knowing that there's a mix of government and industry in the room. Okay, Todd, I think, just gave some pretty practical advice, and I would agree with you that the AI phenomena right now is kind of like the cloud phenomena of last year and the year before. Right, everything's cloud now, everything's AI. We'll start with you, Jonathan, if you don't mind. How can government and industry partner together effectively to maximize the benefits of AI while addressing the risks?
Yeah, so this kind of, I was recently on a panel for a NIST workshop on video analytics for public safety. And, the prime concern there was to keep privacy effectively. So if you're building up data sets and you're building up kind of predictions from predictive models, when does that become a problem? So there needs to be some standards in place in order for everybody to kind of understand where you in terms of the format of the data, the metadata that is associated with it. So standards are a big kind of part of this, I believe. But in order for those standards, whatever standards are created in whichever area that you're working in, there needs to be some way to keep research rich in that area. So a problem that you have with standards is that it can constrain research. It can kind of say, okay, you can't do this particular thing because there is a particular policy in place. So I think where governments and the government and industry can really help one another is to develop data sets which are proxies of your particular problem, as close as possible to your particular problem, which are potentially open sourced or made kind of just available to a select series of companies, such that you can start to develop some really interesting techniques, do some kind of large scale correlation across multiple different modalities, multiple different data sets, combination of sparse and dense data sets, could be really interesting challenges. And those need to be made available to industry in order to develop these applications further, whilst at the same time creating standards to ensure that any risks associated with combining data sets together are addressed. So I think it's a combination of both standards, kind of rigorous standards, but also having data sets and challenges made available such that that kind of rich research seam can be mined. So that kind of examples of this are the kind of Kaggle open competitions and other kind of top coder, things like this. These challenges have really pushed the limits of research and have developed new methodologies, new techniques, and it's all because of allowing the data to flow to whoever is developing applications.
Great, thank you. And so, Brian and Todd, we have about 1 minute apiece. Any parting shots? You could choose to answer that question, or if there's anything else you'd like to highlight for the audience, would appreciate it.
I think challenge problems are really great. Just to chime in on that, I think we need to think about new ways to collaborate, and if it's going to be a spiral, we also have opportunities in integration. So we have a lot of technologies that have come along in the last 10 or 20 years, whether it's AI for knowledge bases, I have robotics I can do a lot with now autonomously, I have a lot more power in networking and cognitive radio, I have a lot more tools, and I'd like to apply AI to integrate those things. And so we need to find ways to collaborate between government, industry, academia in new ways that allow us to do this spiral and ways that we can bring people in when we do integration. I think it's a very interesting, exciting time for sure, and there are a lot of opportunities.
Thank you for all your comments today. It's been fantastic.
So one last, I guess, discussion point here is the abstraction of normalization. I would love to see that. There is nothing unique of a hosted cloud provider's infrastructure, zero. So if I abstract and normalize the ability for code to be inserted rapidly, iterate, collect metrics, and iterate again, it opens up an entire new business process. It opens up an entire new technology stream, I believe. But it also requires companies to rethink how they're coming as an entity by themselves, right? So how do you participate to be part of the abstracted normalization?
Great points. Gentlemen, I really appreciate all three of your participation, valuable insights today. Just to recap, Dell EMC, Nvidia have built ready solutions, pre-engineered solutions that allow you to deliver this computational resource rapidly to your environment. I think we highlighted that we suggest that you get the capabilities on the ground, you bring the subject matter experts that exist in the environment in to determine how you want to use the tool set of artificial intelligence to bear on the problems that are most important to the agency. You build a software factory type approach to deliver these capabilities while having a continuous feedback loop with the actual end user community to continuously build on and improve the capability. Is that a fair summary? Okay, great. Could we please have a hand for our panel?
Thank you.
Thank you all very much.
Thank you.